Hey everyone! Today, we're diving into Chapter 5, Foundations of Ethics, in GenAI. And I know the word ethics can sometimes sound abstract or a little academic, but this chapter makes it incredibly practical. We're going to trace how ethical thinking evolved alongside technology, then connect those ideas to generative AI, cybersecurity, regulation, and real-world decisions. The big theme is this. Technical capability alone doesn't tell us what we should build, how we should use it, or who should be protected. And here's the part one find really interesting. GenAI isn't just another tool that analyzes information. It creates content, imitates people, and can influence judgment at enormous scale. So the ethical questions become much more urgent. As we move through the slides, keep one idea in mind. Responsible innovation means protecting human dignity and autonomy while still allowing useful technology to develop. All right, let's start with how we got here. Let's begin with a quick trip through history, because today's debates about GenAI are actually part of a much older pattern. Plato worried that writing could weaken memory and encourage shallow understanding. During the Industrial Revolution, the Luddites challenged the social cost of mechanization. In the 20th century, the atomic age showed the world what happens when technical power grows faster than moral restraint. Then computers and the internet introduced major questions about privacy, intellectual property, and the responsibility embedded in software. The digital age pushed those concerns even further, especially when personal data was collected or used without meaningful consent. And now we arrive at GenAI, where trustworthy systems are expected to respect rights, fairness, transparency, and accountability. So here's the recurring pattern. Capability expands first. Ethical boundaries catch up later. That delay is where a lot of harm can happen, which is why we need to think about ethics before deployment, not only after something goes wrong. Okay. So, how do we actually reason about an ethical decision? This slide gives us 3 different lenses, and each one answers a different kind of question. First, metaethics asks what words like good, harm, or fairness really mean. Are those values universal, culturally shaped, or dependent on context? This matters because we can't build meaningful rules if we haven't clarified the values underneath them. Second, normative ethics asks, what should we do? Deontology emphasizes duties and rights. Consequentialism asks us to weigh outcomes and overall impact. Virtue ethics focuses on the character and judgment of responsible people and organizations. Third, applied ethics brings everything into the real world. It asks how those values and rules shape decisions about consent, privacy, fairness, data protection, and deployment. And this is the key point. Pause here. A defensible GenAI decision needs all 3. We need clear values, practical rules, and an honest understanding of the context where the technology will operate. Now, let's look at the governance ecosystem. The main idea is simple. There is no single rulebook that covers everything. At the foundation, security standards, such as the ISO 27000 family, help organizations manage information security, controls, and risk. On top of that, AI management standards add governance and lifecycle discipline. So responsibility doesn't stop once a model is released. Then we have ethical principles from organizations and initiatives, such as the European Union, UNESCO, the OECD, IEEE, Asilomar, and AI for People. These frameworks repeatedly return to ideas like human rights, transparency, fairness, and accountability. Global cooperation through groups such as the G7, G20, and partnership on AI helps create shared norms across borders. And notice the connection to the Sustainable Development Goals. Secure digital systems support resilient infrastructure, safer cities, trusted institutions, and international partnership. But, and this is important, broad AI guidance still lacks enough precision for GenAI. The foundation exists, The GenAI-specific details still need to mature. This is where the GenAI gap becomes really clear. General AI rules are useful, but generation creates a different set of risks. If a system can create convincing content, we need ways to prove authenticity and label synthetic output. If it can remix existing work, ownership, attribution, and consent become essential. If it learns from massive datasets, privacy and the treatment of sensitive data have to be addressed from the start. GenAI can also scale stereotypes incredibly quickly, so bias testing can't be an occasional checkbox. It has to be built into development and monitoring. When systems imitate people or voices, we need safeguards against impersonation, manipulation, and deception. And the final capability may be the most subtle. GenAI can influence human judgment. That means preserving agency, oversight, and the ability to challenge a system's output. So, the conclusion is not that GenAI should be stopped. It's that the standards must become more specific, more transparent, and continuously updated as the technology changes. Here's where global governance gets fascinating. The technology travels across borders, but regulatory philosophies do not look the same everywhere. In North America, especially the United States and Canada, the approach is often more sectoral and innovation-led. We see executive orders, agency roadmaps, critical infrastructure priorities, public, private collaboration, and rules that vary by industry. Europe places fundamental rights and risk classification much closer to the center. The emphasis is on data governance, transparency, proportionate obligations, and cross-border harmonization. Across Asia and other regions, policies reflect a wide range of national strategies. Some emphasize data sovereignty and state security. Others focus on human-centric design, public trust, or local cultural priorities. Regional cooperation is developing, but it remains uneven. So, what's the best global outcome? Not forcing every country into one identical model. Instead, we need convergence around an ethical floor, basic protections that travel with the technology, while still allowing local context to shape implementation. This slide is a useful reminder that GenAI is not operating in a legal vacuum. It already intersects with at least 6 layers of law. Intellectual property law deals with authorship, copyright, patents, and attribution. Data protection rules govern consent, lawful processing, minimization, and individual rights. Algorithmic accountability rules introduce impact assessments, auditability, and ways for people to seek redress. AI-specific legislation may classify systems by risk, require transparency, or prohibit certain uses. Consumer and media rules address deception, advertising, deepfakes, and platform responsibilities. And export or trade controls can apply to dual-use technologies, advanced models, chips, and cross-border transfers. Now, here's the tricky part. No single statute resolves the whole system. A product may comply with one layer and still create risk under another. That means organizations need a lifecycle view. Training data, model development, deployment, monitoring, output use, and every jurisdiction involved. Compliance can't be a final legal review. It has to be part of the operating model. So, what would a regulatory system look like if it could actually keep pace with GenAI? This slide gives us 7 design moves. First, adaptive regulation. Monitor real-world impact. Learn continuously and update the rules. Second, convergence. Reduce cross-border gaps that allow regulatory arbitrage. Third, ethics-based regulation. Translate fairness, rights, and accountability into enforceable duties. Fourth, use a risk-based approach. Higher-impact systems should face stronger controls than low-risk applications. Fifth, regulatory sandboxes. Let teams test high-stakes technology under oversight before scaling it widely. Sixth, certification and standardization create consistent evidence for assurance and independent assessment. And seventh, public participation brings affected communities into the conversation, not just developers, companies, and regulators. The exciting idea here is that regulation doesn't have to be frozen or purely reactive. It can behave like a learning system. Because static rules age, but strong feedback loops can keep governance relevant as models, uses, and risks evolve. Now, let's make the risks concrete. These 4 cases look different, but they reveal a remarkably consistent pattern. Facial recognition can support security, but it also creates risks involving privacy, demographic bias, and mass surveillance. The response includes limiting use, auditing performance, and requiring meaningful consent. Deepfakes can spread misinformation, impersonate people, and damage trust. Here, detection, disclosure, platform policy, and enforcement all matter. AI-generated art raises questions about originality, ownership, attribution, and the livelihoods of creators. Responses include updated copyright rules and clear disclosure when AI assistance is involved. Predictive policing can reproduce historical bias and make opaque decisions that intensify surveillance in certain communities. Audits, community engagement, transparency, and redress are essential. And now the pattern. Pause for this. Power is introduced without enough consent, hidden harm accumulates, and control arrives only after damage becomes visible. Good governance tries to break that sequence by anticipating harm before deployment. Let's close with 6 questions that turn the chapter into a practical decision framework. First, purpose. What human benefit are we pursuing, and who could be harmed? Second, data. Is the data use lawful, consensual, and proportionate? Third, output. Can people identify, verify, and challenge what the system generates? Fourth, fairness. Which groups could experience unequal errors, bias, or surveillance? Fifth, control. Who owns the decision, who can intervene, and who provides a remedy when something fails? And sixth, adaptation. How will monitoring change the model, the controls, and the rules over time? These questions are intentionally simple, but they force us to look beyond technical performance. A model can be accurate and still be unfair. It can be innovative and still undermine trust. So here's the bottom line. Responsible GenAI protects dignity and autonomy through governance that is specific, risk-based, and able to evolve. That's not a barrier to innovation. It's what makes innovation sustainable and worthy of trust.